Select the major product of the following reaction sequence. So we need to look and see what we are starting with. So we are starting with a primary alcohol. And we are reacting this first with chromic acid. Right, so we might see chromic acid as H2CrO4. That's the actual structure of chromic acid. This is often generated in situ from sodium dichromate and sulfuric acid. So you might see these conditions, or you might see chromic acid, but it's going to do the same thing. And so what we want to recognize is that this is a really strong oxidizing agent. So when you take a primary alcohol and you subject it to this really strong oxidizing agent, chromic acid, what happens is you're going to oxidize that alcohol to the carboxylic acid. So you might recall that with primary alcohols, you could, if you used a milder oxidizing agent, you could oxidize a primary alcohol to an aldehyde. And that's a reaction that's going to be important in later chapters. So you might want to refresh your memory on what reagents would allow you to take that primary alcohol and make the aldehyde. In this chapter, we're looking about carboxylic acids. You're probably more likely to see this reaction. All right, so after that first step, you've got a carboxylic acid. And then what you're doing is you are treating this with an alcohol, an acid, and you're heating it up. These are the conditions for a Fischer esterification. Okay, so there is another video that shows you the whole mechanism for a Fischer esterification. It is a long mechanism. All of your acid catalyzed mechanisms are really long. But if we're looking to predict the product, we want to recognize what is attached to our alcohol, and that is what's going to be forming a bond here. So I'm not implying that you're breaking that covalent bond. This attacks as a neutral molecule. I'm just trying to identify the portion that's going to end up attached to that ester. So we would be making, if we're starting with ethanol, we would be making the ethyl ester. And so you can see that that is option B. Okay, so again, long mechanism, it's worth looking at. There is a separate video that runs through the Fischer esterification mechanism.